All right, so welcome in our stage, and with that, I will leave and I will give the virtual microphone to Shailvi.
Thanks so much, Mate. Let me share my screen also really quick. Okay, hopefully you can all see my screen. Thanks everyone for joining in today. My name is Shailvi Wakhlu, and today I'm going to walk through dealing with bad data in healthcare context. I hope you're all as excited about exploring data anomalies as I am. A little bit about me. I've lived in a bunch of different cities across the world: New Delhi, Chicago, Prague, and right now I live in San Francisco. I've also had the pleasure of working with a lot of different companies in the Bay Area and elsewhere, and these are some of the more recent ones. I've woven in and out of healthcare and got to pick up some useful context as I worked on medical data, as well as patient and care management systems. Now, I'm the director of data at Strava. Strava is the leading social platform for athletes and the largest sports community in the world, with over 70 million athletes in 195 different countries. We're growing rapidly and hiring if anybody would like to connect. So first, what is bad data? Bad data is anything that is inaccurate, incomplete, or misleading. You can usually notice it when an analyst encounters it because they get real mad whenever it shows up, and it has now potentially ruined their next couple of hours, days, maybe weeks, I hope not. So today we're going to discuss what we can do about bad data. We can prevent it, we can diagnose it, and we can cure it. I'm actually going to spend the bulk of our time today at the prevention stage. Understanding prevention is the best way to also get better at diagnosing and curing it. So let's dive in and understand the prevention stage and see how bad data gets introduced. All data goes through a similar life cycle. First, we define the features and align the different teams on those definitions. Next, we work on logging the data to track and store it. After that, we use some business rules to transform that data into a usable format. Then an analyst is able to interpret the data to solve some business problems. And finally, the data results are shared with the stakeholders. And that wraps up the data lifecycle. Now, we have identified the data lifecycle, and you'll start to see that at each phase, there are numerous possibilities to unintentionally introduce bad data. There's a lot going on with this graphic, but I wanted to show the full picture before I dive into each of the sections. I usually have this graphic pinned somewhere to remind me of all the possible places where my data might be getting corrupted. So let's jump into each of the sections before I come back to this visual. I'm going to anchor a lot of the examples to COVID-19, since that is unfortunately the theme of 2020. But hey, there's a vaccine around the corner, so maybe next year we can pick some other fun anchoring. Let's say you're trying to track COVID cases in a population. You are relying on data filled out per patient by healthcare workers. How do you define the various pieces of data that you want to track? A lot of issues can arise based on how specific or flexible that definition is. So your feature definition may outline that a diagnosis for COVID means that they count as a positive case. But what about people who were asymptomatic and never received a formal diagnosis? They still might test positive for antibodies, which means they did have the disease at some point. And so what do you do with that? Should that trigger a case flag? So in the case of COVID, it's a widely reported and well talked about disease. So you might end up taking a call very specific to the COVID scenario, but it may not be something that's super consistent with how you deal with caseload criteria for other diseases. And that means, in a sense, you are using uneven logic, which might result in the creation of bad data. Occasionally, you can also have something that is a very, very narrow definition that just doesn't include all the scenarios. You pick a definition that fits today's use case, but it doesn't really account for tomorrow. That may also cause problems when you try to catch up with the pitfalls of that narrow vision and end up having to spend a lot of time fixing it. And sometimes it's just plain old human error. Maybe your definition logic is correct, but a typo causes a different disease with a few letters here and there to be picked up in the case statement. These kind of errors are actually relatively common. Eventually, a bad definition is causing you to miss seeing a clear picture. Your picture is a little blurry or it's oddly cropped out, and inherently, it's just not a picture of what you wanted to see in the first place. Next is the logging stage, where you actually track the features you have defined, usually with the help of engineers who are tracking it in as part of your pipeline. There's a lot of potential for confusion and inaccuracy at this stage. So your tracking itself might be incorrect. Perhaps the engineering team is only logging a subset of the information or is logging the wrong information. You were maybe expecting all COVID patients were being tracked, and instead you only have COVID patients who have insurance because you're relying on insurance companies to give you that data. Maybe you're actually logging all cases for patients with or without insurance, but you're just logging them at separate places. And the fact that you're logging it at separate places, maybe it makes it harder for you to reconcile that information later, especially if you don't know if there are unintended duplicates. For example, people who show up in both data sets because they didn't realize they were covered by insurance when they first came for treatment, and later that they got reimbursed. So maybe for Europeans, this example is a little hard to relate to, but in America, this is a real thing that happens because our insurance system is pretty interesting. So your pipeline also itself can be faulty. Maybe there are certain exceptions where it just doesn't track the data. For example, your healthcare worker is using a mobile app to fill out the case details, and in most cases, you're assuming they use a web platform, and that tracking is just misaligned with the web tracking in some way. Or you could just have a pipeline that's broken for other reasons and something that goes unnoticed for long periods of time. In some of those cases, you may actually have no way to retrieve the data at all. Another common problem is time frame issues. It shows up in a lot of different ways, but how long is data being stored for? When does it get aggregated? What time zone is being used? All of these issues, if they're not ironed out, they can really cause problems. Ultimately, if the connection is broken between the data that you want and the data you're actually tracking, then you're going to end up with a lot of unintended consequences. So next up is the transforming phase. And just like baking, if you're taking a bunch of rules and transforming raw ingredients to a finished product, a lot of mistakes can occur. With data, you need to take that raw data and convert it to something usable. Otherwise, every baker will create their own recipes and make a different product. First part of that is making sure that the rules are understood. When two humans look at a piece of data, they might make different assumptions about why it's there and what it represents. You are seeing the cake in front of you, but you're unlikely to know exactly what recipe was used and what ingredients it contains, and you'll just take your best guess. Similarly, when someone wants a table to contain per day the number of COVID cases, without more context, you really don't know if that number represents new cases, cumulative cases, or just all current cases where someone is diagnosed but hasn't yet fully recovered. Depending on what assumption they make, the data can be used very, very differently downstream. And unless everybody uses the same policies of labeling data, it can cause a lot of confusion. Data dictionaries are something that really help in this regard. How data is aggregated can also be very impactful in how useful it is. If your data is not incrementally aggregated, then you may need to go several steps up in the pipeline to get to the raw data that you need, or just in general, jump through a lot of hoops trying to use the aggregated data for your specific purpose. Either ways, being thoughtful and aligned that the aggregations for with the specific use case that you're building for, that can save you from a lot of data gymnastics at a later stage. Finally, you can have logical errors while transforming data. Human error shows up in every single part of the data lifecycle, and transformation is no exception. We're now on to the fourth stage of the data lifecycle, which is analyzing. This is where the rubber meets the road, and you start actively using the data as an input for key decisions. First step is the problem statement itself. Stakeholders and analysts can easily be misaligned on the question that they're trying to answer. That misalignment leads to assumptions that are expensive to fix once all the analysis has already made significant headway. The rework and the resentment that follows can all be avoided if there is clarity about what problem is being solved and what those nuances mean. Besides that, while analyzing results, again, there is a capacity for human error if you use the wrong model to solve your problem or just made a mistake in your calculations. The last thing to watch out for is bias in your algorithm. This is a pretty large topic, and honestly, it's a whole talk on its own, but I'll touch on it very briefly. Inherently in healthcare, the consequences of getting things wrong can be really intense. You have the capacity to negatively affect the disease burden of entire populations if your algorithm is biased. If you used a biased data set to learn about how a disease progresses, and it only includes data points from a very specific demographic, your published insights can actively harm the underrepresented demographics that weren't included in your original data set. Unfortunately, there's a lot of really blatant examples of this in the industry. For example, women being more likely to die from a heart attack because their symptoms were different from those of men, and that inherently led to a poorer diagnosis. Those early heart attack studies did not include women, which meant their symptoms were not widely understood and reported, and that is what led to the poorer diagnosis. Similarly, there were differences along race, which led Black women to have a higher pregnancy-related mortality rate due to systemic racism that provided them inadequate and inferior care. Here again, it was the lack of data and research that quantified the problem, and that led to this issue being ignored for decades, because Black women dying during childbirth was not something that was seen and tracked in the aggregate, and thus it led to a lot of bias. Essentially, there is a lot of thoughtfulness required to make sense of the data and extract the right insights at the analysis stage, and to not make unintentional errors. Lots of folks may be tempted, for example, to treat any incidence of breast cancer in men as bad data and just remove it from their analysis. But depending on the situation, even though men have it at low rates, it is still relevant, and it might actually be very relevant to your analysis. You may be throwing out useful data for transgender patients who are also historically underrepresented in optimized healthcare outcomes that serve their unique needs, and you don't want to do that. So you have to explicitly be a little more thoughtful in how you treat your algorithms. And now to the final stage of the data lifecycle, which is sharing it. First, I'd like to draw your attention to this very real, legitimate chart that was used by ABC about what worries people about COVID. There's this whole fun color scheme going on that's just 3 shades apart. And the real genius is obviously a pie chart that adds up to 178%. I mean, who doesn't like pie with extra 78% piece? A colleague of mine shared this with me recently, and I couldn't stop laughing at how bad the visualization was. And it was from from a reputable source. So I was really surprised that they used it. Sharing data, I think, is often the part where a lot of inaccuracies and misrepresentations show up. In general, people need to be very, very careful about what is the story that they're trying to tell and what do they want viewers to take away from it. Faulty reporting can include data results that are constructed incorrectly or have typos. In such cases, it ends up starting a whole cycle, since that same faulty data may spur further analysis that is also inaccurate. This could be in the form of reports, data stories, or visualizations. A good practice is generally to remove any data being shared that doesn't have an active owner so that nobody is getting inaccurate reporting. Next thing to worry about is misinterpreted results. When COVID data was initially shared, I saw a lot of examples of charts in reputable publications that just, they really didn't take the extra 5 minutes to clearly label their charts. So there was missing keys, labels that are, they should have been right next to the chart, but instead they were somewhere in the fine print or somewhere like in a paragraph somewhere. And people ended up missing those caveats because you just couldn't find it easily. It was hidden away in some tiny text. There was also a lot of cases of things being sensationalized when the raw numbers just looked terrible. And when you normalized it by population size or some other factors, it was actually not that bad. But that kind of misrepresentation can have very dire consequences in healthcare as policymakers and citizens react to misinformation and end up focusing on things that are really not of the highest priority. And finally, a very common problem at this stage is that once you give people access to some data, they are free to use it in other analyses. Some of the use cases really may not be aligned with what the data truly represents and what it was intended to be used for. You can't always stop people from doing that, though at the very least, from your own side, you can be thoughtful about including the nuances of the data and have some documentation that helps any potential downstream users to understand here's what the data can and cannot be used for. So that wraps up our prevent stage. Once again, remember to keep in mind that there's a lot of different ways that are very common to introduce bad data. This is not meant to be an exhaustive list, but rather a mind prompt to help folks easily identify the various things to keep in mind. Hopefully, once we understand how bad data gets created, it becomes a little easier to diagnose what's going on. There's some very common ways that people take notice of bad data. Usually, data has some source of truth or something that you just trust a lot, and some other data shows up that doesn't match in absolute or in aggregation and just generally seems mismatched with what you already know. Other times, you see a data result and it just doesn't make sense. It's not logical. Sometimes it actually might be the right answer, but it still warrants an investigation because it looks suspicious. Either ways, the first step is to look for very obvious reasons why you're encountering or suspecting bad data. First obvious question to ask is this really bad data, or do you just not like it? Were those two numbers really supposed to match, or were they always meant to represent completely different things? And the suspicious results, what assumptions have led you to have those suspicions in the first place? Then you can look at your data set. Was it even built for the use case that you're trying to use it for? Are you just looking for the right answer, but in the wrong place? And finally, there is some unknown bug or pipeline issue, which means your bad data issue is either temporary or has a known fix that you can dive into. If none of the above reasons are the answer, then it's time to be methodical and go step by step to find the root cause. Start with the data lifecycle in reverse order. For each phase, verify if the phase before it has the right data. This will help you identify exactly where in the lifecycle something is breaking. When you find the phase where the data is breaking, go through the common root case examples and create a hypothesis about what might be happening. Create hypothesis, test, and validate, and keep repeating that process until you find something that explains your issue fully. Final sanity checklist is to just logically go through your problem and document what you know and what you need to figure out. I like the journalistic favorite questions of trying to document a story and focus on the what, where, when, why, who, and how of the problem. As I go through this, it helps to rope in other people to talk through my logic, or even look up data dictionaries and other documentation to validate my initial assumptions. The truth is out there. You just have to keep breaking down the problem until you can find the specific issue. Once you diagnose bad data, curing it is a lot more straightforward. When you have correctly identified the problem, the solution will be straightforward. The diagnosis will tell you where the problem lies, and it isn't always going to be in your hands to fix it. The data lifecycle has many parts, and any of those parts could have an issue which has multiple owners, all of whom need to come together to fix it. Also, do keep in mind that you can't always fix all the issues for the past, unfortunately. Sometimes something that broke causes a permanent and unfixable gap. However, you can cure the problem, at least for the future, and add guardrails in place to flag issues going forward. For the data folks in the audience, here are some of the most basic scripts that you can write to fix issues faster, which can result in less data corruption. The more familiar you are with your data and its typical common problems, the easier it is to write common scripts or even make visualizations that can make it easy to quickly pinpoint and fix problems. A basic volume check, for example, across different sources to see if you're consistent with at least the rows of data. And if not, then it means that it's more likely that the content of those rows is what is causing the problem. Things that can help you quickly identify missing data or the data that is duplicate can also be very useful to quickly narrow down what it is that you need to fix. And finally, just being able to break down the data by different dimensions can really help, especially when the data is really large and small volume changes are noticeable. You may realize that in general, your data looks fine, but there's this one whole disease area that has corrupt data due to a typo, or there's a certain drug type that has too many ingredients that keep cross-referencing each other, and that breaks some back-end automation or something that you were trying to do. So being able to break down your data by different dimensions can help narrow down some of those problems. Some coding practices as well that can help you stay very consistent. Create reusable modules. You will thank your past self when you're in a time crunch and need to check a bunch of things in a very short amount of time. Document well and centralize your code to make it accessible across your team, which helps build consistency. And finally, add alerts to your pipeline. Over time, you will get good at knowing what thresholds are normal and what should cause you to immediately launch an investigation. And if you're not a data person yourself, like, feel free to tell the data people in your team to go ahead and implement some of these practices. So last reminder, prevention is always better than cure. Just like healthcare, data has the same rules. This is, there's always a more detailed data lifecycle checklist that I referenced earlier that can help look at each phase and find ways of preventing bad data. And there are also some other simple generalized strategies that I've listed here that can help you early on. So things like reconciling your terminologies, make sure everybody in the company is speaking the same language and using the same terms. That can help cut out a lot of mistakes. Automate and simplify whenever possible. Try not to do anything manual. Create an actual governance strategy early on, and that can also save you a lot of headaches at a later stage. And finally, at regular intervals, do an audit and figure out what strategies and processes are working for you, and have a way for folks to flag inconsistencies or stuff that's broken. And with that, I wanted to leave you all with some additional research and reference material. I also have more specific coding examples in one of my other talks that is linked on my website as well. Thanks all so much for attending the talk. I know this is the last talk of the evening. Well, it's still morning for me, but I hope you found the content useful. I'm also really grateful to the Crunch Data Conference team for organizing this meetup and for hosting me. I had originally attended Crunch back in 2015 when I worked at Prezi, and it is such an honor to be still connected to the conference in some way. I'll be taking some questions now. Keep in mind that the content will be available later online, and I'm also happy to answer follow-up questions via Twitter if you want to connect with me there. And that's it.
Thank you very much, and it was really great to have you back. And even if it's not the same setting, please to say. So my question is that for instance, I advise companies on data infrastructure, and obviously data quality is a big issue because many times people just want to get data as fast as possible, and sometimes that goes against the data
Goes
quality.
against the data.
And what I wanted to ask you is that if sometimes these people have objections to spend time on prevention, as you mentioned, good coding or just software engineering principles. So what do you see as a good counter argument when people want to rush things and they want to, because I think data quality is sometimes tricky because it doesn't right away, right? As was part of your presentation, is that how it can surface later on.
Yep.
So what do you suggest as a good counter argument when people want to cut corners and maybe go faster, even though we have a feeling that we might sacrifice data quality on the long run?
Yeah, absolutely. That's a great question, and I think over my career, I've seen sort of all sides of it. Like, and I definitely have worked in some settings where people are more interested in chasing the shiny object rather than fixing all the data quality issues. And my counter to that is pretty simple. If at the end of the day you're in a business to make money, and you want to maximize that money, then just be very aware that data quality issues, you don't always know how they're going to affect you later on, but they do have the capacity to cost your company a serious amount of cash if you don't spend the time upfront to fix it. And it can happen in a lot of different ways. Like, maybe there's some data that actually helps you make money and you're just sort of losing that, or you lose big chunks of it. You could also really lose trust with your customer, where some data quality issue is, either it becomes public or it causes a lot of issues for your customers. And if your customers stop trusting you, you don't have a business anymore. And that's inherently reason enough for you to sort of be more upfront about it and try to tackle it sooner rather than later. And besides that, I'd also say that it's costly to sort of fix things at a later stage. If you fix it earlier, usually, yes, you waste time of the sprint, like, so to say, to fix something, but as the problem gets bigger, it becomes more expensive to fix it. And your data team is going to be super unhappy because nobody likes working in an environment where you're constantly dealing with these issues. So if nothing else, do it for the morale of your employees who'd really appreciate having cleaner data and more curated data to work with.
Yeah, I assume especially analysts and the downstream users who have a hard time figuring out like just what to do because the data is messy and stuff. Yeah. And to hit a more personal tone, and a question that came up is that what is the biggest data quality issues or data quality related challenges that you're facing at Strava?
So fun fact, I actually just started at Strava a month ago, so I haven't fully dove into all the data quality issues that Strava is facing. I'm really too new for that. In the future, like, again, hit me up at a later stage, and I'll definitely answer that question with more understanding of Strava.
Previous, because you have a unique insight into different companies. So what would you say? I don't know if you want to name those companies, especially. Problem, but like maybe just as a patterns, or what patterns do you see, or what would you say that because some people have to take what you say or what we say at face value because they did not actually get to the point where they were hit by these issues. So what can you say, that what kind of issues that you faced, kind of like as a cautionary tale?
Yeah, absolutely. And I think the ones that I think are most relevant, so I've worked in a lot of B2B companies, and in those enterprise companies, typically you're acquiring data from a bunch of different sources, and pipeline issues are, I think, some of the most gnarly to resolve, because you're in some cases you're actually paying vendors to sort of be a part of your data pipeline in some way. Either you're getting data from them, and you might be sort of having something plug into someone else's data as well. And I think those things, because they have so many, like, it's a whole sort of sequence of events that needs to happen for you to get to your final, whatever you're doing with that data at the final step. Like, it's all of it has to be perfectly executed, And if you don't build in that padding of like, hey, something might go wrong and I might not get this data at this time that I'm supposed to. And it could even be internal, it doesn't have to be external. And if that ends up sort of breaking this entire sort of sequence of events that was supposed to happen after it, it's really frustrating to resolve, because the final end consumers are unhappy because they were expecting data Monday morning and it's not there. And now you have to sort of go back and keep doing that. And I've seen that show up in so many different ways. And, that's why like the whole have an early alert, so that any problem, any part of your pipeline, you immediately sort of start looking into it and fixing it, and preventing that data loss that happens can really sort of help you in that.
And do you think that over time we have, so now, do we have better tools now affecting data quality, let's say 5 years ago, maybe more? But because many tools like in machine learning, data engineering had that kind of rapid innovation in terms of tools. And sometimes I felt that we have a lot of innovation in the computing part, a lot of in the processing part, but do we have that same kind of innovation or same kind of progress in data quality? What do you think about that?
Yeah, I think there is an intention in the industry to sort of start, there are some, I think there's a lot more tools that, at least, I don't know, whatever I've come across, like there's a lot more tools that are working on sort of the pipeline problem of like consolidating stuff, making things easy for people to access, democratizing that access in some way. And I think finally, like even on the visualization side, I do think good visualization can actually help you spot a lot of these errors really quickly. So if that stuff is made easy, you can, sometimes you need to write a script, sometimes an easy visualization can help you spot it quicker. So I have seen some tools, like there's a few data dictionary tools out there that make it easier for people to label stuff and track stuff, so that there's a centralized place. Like people are never going to go dig up a Google document to see what a table actually represents. But if that information is right there, like even in Snowflake, you have the capacity. I'm a huge fan of Snowflake, by the way. So, Snowflake, you have the capacity to sort of like put it right there. Like this is like some notes or some comments that anybody who's using it can kind of access that really quickly. And those type of things, I think, allow people to just understand stuff faster. And the more you understand something, the less likely you are to make a mistake in using it.
Yeah. All right. That was really useful. And I'm glad that you could share your experience, because I think you have a really interesting experience around this specific topic. And I just want to say thank you very much for I'm happy that we could manage this, even though we're probably in a different time zone, because it's for me, it's more like evening time. Yeah. But thank you, Shailvi, very much. It was really, really, really useful. Thank you.
Thank you so much, Mate. Thanks for having me. Bye.